a lot. Thanks for coming, everyone. Just before I begin, I just wanted to have a brief show of hands of who's kind of familiar with what a blockchain is. All right, that's awesome, great. So, yeah, as mentioned, my name is Sid. I'm a co-founder of Token Analyst, and we're basically a London-based startup that's focused on trying to bring more transparency into this whole crypto ecosystem. And the way we're trying to do it is by analyzing the data that lives on the blockchain itself. And so, as a brief summary, the blockchain essentially at its core is, if you really boil it down, it's just a database. It's a database of transactions. So whenever one person transacts with another, say I send Bitcoin to someone here, that transaction will be bundled with other transactions that have occurred at the same time and into a data structure called a block. And these blocks are linked to each other cryptographically so that we can then have a shared history that anyone in the world can then access and see exactly who owns how much of each crypto asset. And so at its core, it's just an open database that's accessible by basically anyone, especially for some of these open crypto assets like Bitcoin and Ethereum. And it kind of makes obvious sense to look at the data that's on the blockchain because it's fascinating and super interesting. But what we see today is not many people are actually looking at this data at its core. And the reason being that obviously in the crypto ecosystem, a lot of interest has been around price, around social sentiment. We've seen a lot of millionaires made out of Bitcoin in the past couple of years. And even recently, April 2nd, Bitcoin went up 15% in a single day. And so a lot of the attention is on the kind of the tip of the iceberg, which is the price, and on social signals, like what's the narrative on Twitter, for example. And not many people are trying to answer the kind of core fundamental questions like who are actually using these crypto assets and what are these assets actually being used for. And for us, the real light bulb came on when we realized that we can look at the transactional data that's on the blockchain to try to answer some of these fundamental questions. And by answering these questions, hopefully we can also arrive at some sort of fundamental valuation of these assets. So what is a Bitcoin really worth? To really try to drill down, drawing a parallel to traditional markets where there's fundamental indicators like 10K reports and annual statements that simply doesn't exist for crypto assets currently. And so the way we tried to look at it was, when you just look at the blockchain data in and of itself, it's just a bunch of random hashes like you see here. It's every time I send a transaction, I'm assigned an address or a wallet on the blockchain, which is a cryptographic hash, and that hash is sending a transaction. The transaction's value is known, but when you look at it, the entire data set is just comprised of hashes: transaction hashes, address hashes, function call hashes in the case of smart contracts. And so how we tried to look at it was, can we take apart these hashes and try to figure out who is behind these hashes? And so essentially converting address hashes into entities. So different types of entities. So an entity can be an exchange like GDAX, or a bot-like entity or a human-like entity. And the way we really tried to go about this was to put a spotlight on the address or the user account. And from a data science perspective, looking at the different behavioral characteristics of each of these addresses. So some of these characteristics include things like how often does this address transact in a given day, in a given month, in a year? What is the transaction volumes of these addresses? Does it send millions of Bitcoin in one go, or does it send cents on the dollar? There's a whole bunch of features that we look at internally, but in a bigger picture sense, is essentially looking at the behavioral patterns, how the address behaves on chain, just by looking at the transactional data, to then try to figure out what type of entity this given address is. So to give you a simple example, last Friday we saw a group of 16,000 addresses transact at the exact time at 12:05 p.m. UTC. And we traced it back across the entire history of the blockchain. We saw that this same group of addresses had transacted at the same time every week for the past 2 years. And so common sense would tell you that this kind of behavior is somewhat automated, by a script of some sort of bot behind it. And so that's essentially was a heuristic for us to try to label similar categories of addresses, similar clusters of addresses on the blockchain who behaved in similar ways. So what we end up at is essentially a mapping of these token ecosystems. Over the past couple of years, there's been hundreds of tokens that have been built on top of public blockchains. This is an example of one, Omise Go. And each of these tokens has a rich ecosystem of actors who are interacting, who are transacting with these tokens, and spending them. And what we're trying to see is, who are these people, if they're people at all, right? And the colors here essentially represent different classifications of entities that we have tagged. So in the middle are the pink, all the pink nodes that you see are actually the developers of the token mechanism. So the developers of the token smart contract, which actually mints the token, which creates new tokens out of thin air. The developers of the token exchange contract, which is in charge of transferring the token. And so the big pink dot you see over here is actually the lead developer of this token. And lo and behold, he or she holds a large percentage of the token supply. It's in crypto terminology, they're a whale, essentially a big mover and shaker in this ecosystem. And so when we see these whales move their funds onto crypto exchanges, it's essentially a signal for some sort of price volatility. And so that's kind of how we tie this ecosystem together. Another interesting example is the light blue in the corner over there. This section over here. It's actually the cold storage infrastructure of an exchange. So this is wallets, addresses, where the keys are held offline. And a large percentage of funds for a lot of the crypto exchanges in the world is actually held in cold storage addresses. And so mapping these different actors is extremely interesting. And it's an opportunity that hasn't been afforded in traditional markets because you can't really tell whether a certain transaction is due to a large whale institutional hedge fund making that transaction or not. You just see the transaction appear and the price volatility shift on exchanges and you see the orders. And here, when you really look at the transactional data, you can get some fascinating profiles of these different types of users. So what we've been doing is essentially developing like feature profiles. So trying to dissect these addresses into different types of entities based on their behavioral patterns. So how does a token team member behave? How does a decentralized exchange behave? How does a centralized exchange behave? And what are the kind of features that tie their behavioral patterns together? We're able to do this by, again, looking at the transactional data, slicing and dicing it, and then also comparing it historically to see whether these behavioral patterns kind of exist continuously. It's almost like an archaeological record of sorts, where you look at a rock and you see, do these patterns, have they existed over time, and do they continue to repeat themselves as time goes on? And so some of these patterns essentially ossify, and we can more and more accurately classify different types of entities. Each entity, we give them a probability score internally to say how sure we are of their classification. And what this ends up being is taking this raw blockchain byte data, which is essentially hashes, into kind of clean, classified transactions where we have some sense of who are the entities that are behind these transactions. So we can say for a given token transaction that it's between a human and an exchange, for example, or between a miner of a block and an exchange, when a miner is liquidating their block rewards or the funds that they've gained from mining a block. And so this sort of analysis is really interesting when we apply it to the financial ecosystem of crypto in general. And that's kind of our core focus at the moment. So this is some of the work we've been doing recently, where we've been tying the on-chain data to the data that's off-chain. So the off-chain data in crypto primarily is exchange-based data. So the data that lives on the exchange's centralized servers, which is not recorded on the blockchain, but essentially what we're able to do is we see the flow of Bitcoin or Ethereum from a trader's wallet to the exchange's wallet which is on the blockchain, after which it goes off-chain to their servers where the order is actually made. And so every institutional trader, they really have an incentive to not leave their funds on an exchange for too long because they don't control the keys to the wallet once it's on the exchange. So to minimize their time on an exchange, as soon as they deposit a large amount of crypto into an exchange, they want to make the trade as soon as possible. And so in an example like this, we see a whale trader depositing several million of Bitcoin into an exchange wallet, and we know that most probably there's going to be a series of big orders made on the exchange shortly thereafter. And so we've been tracking order book data and trying to join that with the on-chain data to really precipitate price volatility and price movements. And so, I mean, this is a recent analysis of the price spike of Ethereum on April 2nd. We saw some really interesting behavior in terms of the flows of funds, not only internally flowing into exchanges from traders, but also between exchanges. So this is super interesting because it essentially hints at some sort of collaborative activity happening between exchanges, either to manage their liquidity, because a lot of the funds may be stored in cold storage, and to deal with increasing demand, unexpected increases in demand, and also perhaps some of the under the table stuff that happens in this industry, all the time. And a lot of the analysis is really fun, but one thing to really stress here is building this data pipeline to get to this fun stuff has been no joke. It's been a tremendous data infrastructure lift on our end to make it scalable so that we can onboard new blockchains, new tokens, new assets, and also make it efficient so that we're not burning through our server bills. It's already at a few K every single month. So to give you an overview of our backend a little bit, so it all starts with the nodes. So every blockchain has peer-to-peer node clients, which are essentially servers that we run with the specific blockchain's node client. For Bitcoin, it's Bitcoin Core. For Ethereum, it can be Geth or Parity, which is you can think of as kind of like Microsoft Windows or Mac OS. And these nodes interact with the blockchain itself. They're an interface to the blockchain. We get the data from the blockchain, and then we have a series of scripts, Python and Scala scripts, where we parse this data to essentially extract the semantic meaning, the transactional behavior meanings, what types of logs and events are emitted from each of these transactions, and every single granular piece of metadata that we can get, and we try to do this in real time. So, we have nodes situated all over the globe. We have AWS as a backend, so we do multi-region deploys, and so that because it's a peer-to-peer system, we want to be exposed to as many peer nodes as possible so that we can get the transaction as soon as it's broadcasted. As soon as I make a Bitcoin transaction, that transaction is broadcasted to a node somewhere in the world, which then eventually finds its way to a miner, which includes it in a block. And so we want to get to the transactions before they're even mined onto the block. Because for our use cases, especially from an institutional and from a trading use case, you want to know when large transactions happen as soon as possible, so that you can long or short or do whatever you need to do before the price action actually happens. And so we use Kafka streams for our real-time streaming infrastructure, and then we put it in a data lake, flat files, Parquet, JSON, Avro, and then we also use a graph database to do some of these clustering and hop-based analyses. So if I transact with you, you transact with someone else, that someone else then sends it to an exchange. We want to know those 3 hops in real time. And so we use Neo4j for a graph database. It's been a good experience. And then, of course, we have a whole series of models that we run where essentially it's a combination of traditional machine learning models along with heuristics that we've learned from just examining these different assets. So a heuristic can be, what does bot behavior look like? A heuristic can be, what does a specific type of smart contract behavior look like? And so combining these heuristics with traditional unsupervised clustering models to essentially assign labels to these addresses on the blockchain. And we're moving towards a real-time classification system, but this is obviously hard because when you transact with the blockchain, you can generate new addresses in real time. And so the flow of funds to that address is really the key to then link it back to an address cluster, which is then identifies what type of entity is behind that cluster. And so we're moving towards this. And then we're also trying to tie together some of the off-chain data. So the data that lives off-chain includes, labels or forum posts or all kinds of contextual data, metadata that we can get from the web to provide some type of context to what's going on the chain itself. So that's just a little look. But the real, focus on this is the nodes. So is a look at one of our full node instances. It's we call them a beast mode instance in Token Analyst, and essentially it's a 64 core instance. We had to run multi-threaded processes to just get all the data. So one thing to keep in mind is these node clients are open source software projects essentially, and they're pretty new, and so they break a lot. They're just made by developers all over the world who are collaborating, often for free to try to make these clients. And so when you're using them in production to try to get the data at scale, you really have to optimize a lot of the processes. And also, it's not enough to just have one node. This is just a look at when we deployed, several hundred nodes at once. Monitoring these nodes in real time has proven to be quite a challenge. Not just the hardware monitoring, but each of the processes in terms of the nodes there. We've submitted several PRs to the node clients to try to optimize them because I'm not sure many people across the world are trying to do this at scale like the way we are. And it's very new technology, and PagerDuty has been a godsend for us. We get alerts in Slack. They recently went public last week where, when either one of the processes of these nodes fails or, one of the parts of our ETL data pipeline fails, we get alerts, and that's been hugely helpful for us, going forward. And somehow, we try to tie all of this together into something that's usable. So you can actually do this today. You can go at docs.tokenanalyst.io, and we have an npm package where you can just say npm install Token Analyst and get a live stream of classified transactions to your computer for free. And so this is directly from the blockchain. It's a WebSocket connection to our servers. And this essentially allows us to build add-on services like alerts, like bots that are delivered through Telegram, through Slack, and a live feed on our website of the raw transactions at the top, and also the significant transactions that are outliers that you should really watch out for. So this data, obviously, it takes a lot to bring it together. But once it's in a stream type of format, it proves to be really useful. And similarly, you can go to our website. We're constantly trying to add new features to try to make it more useful. This is the Binance exchange, one of the largest exchanges today. And we see the inflow of funds flowing into that exchange during price spikes, and also the outflow flowing out of it. So essentially, you can develop a sort of metric of how much money or how much crypto is actively being traded at any one point, because you can see the inflow and outflow from exchange wallets. Mind you, to identify these exchanges wasn't that easy. So something we did recently, a couple of weeks ago, was manually transact with every single exchange, send Bitcoin and Ethereum, and get the initial starting point for each of those exchange wallets. So when I send money to an exchange, I interact with a client wallet that the exchange generates for me, and that client wallet then routes the funds to routing addresses, to hot wallets, to cold wallets, and we essentially trace the flow of funds as we transacted with them to really get our accuracy levels higher. So yeah, that's us. We're a team of data scientists and research oriented folks in London. We're always looking to hire. Look forward to chatting and open to any questions.
Thanks, Sid.
Yep.
Thanks a lot for the talk. I didn't completely understand the part that you said that if you had a whale, they would want to put it on the exchange and then trade out of it as soon as possible. Mm-hmm. I thought it would actually be the opposite, because they might not want to leak information about what they want to do, so they might want to just stay there and then take time before they do anything.
Yeah, I think that's a fair point. The thing is, especially in the crypto space, exchanges as a whole have been completely unreliable. They crash all the time. People have lost millions. There was a Quadriga CX situation a few weeks ago. And so from what we've seen, at least matching order book tick level data to the on-chain inflows, at least for the real whales, so to speak, so above 10 million, they prefer not to hold funds on exchange. We've seen identical outflows as inflows across multiple transactions, not in a single transaction, but with timestamps, we can kind of match that to orders. So just a custody risk, essentially, because on your personal level, you own the private keys to the wallet that holds those millions in funds. And as soon as you deposit an exchange, the exchange holds it. And it's not just exchange crashing, but also withdrawal. So the exchange-to-exchange flows that I showed you earlier, this right here. So part of this was because different exchanges have different trading pairs of tokens. So a lot of traders want exposure to different altcoins, different coins that are on different exchanges. So transferring within exchanges and out of and into other exchanges is actually super key.
How do you deal with the different exchanges using mixers between each other?
Yeah, it's a good question. It's a big problem, but at the same time, because we've kind of identified the routing addresses for each of these exchanges, we're able to trace with a certain degree of certainty to where it ends up. So each exchange generally needs to maintain the liquidity to serve their traffic, and so when we're matching it with their order book patterns to see the orders and the type of volumes that are traded on the exchange, the reported volumes, we try to match it with the on-chain volumes to see whether there's a match. And when there isn't, there's either A, they're not reporting their volumes accurately, which happens all the time, or we're missing something in our routing.
And I have a question related to the machine learning part in your whole analysis diagram. And it's not very clear. What are you really trying to predict anything or classify anything? What do you try to achieve in the machine learning part?
Yep.
And related to that, are you using machine learning try to classify a node, whether it's a bot or human or exchange?
Yeah, precisely that. So
Anything else
So as of right now, the majority of our focus is in clustering algorithms to try to. So there's no ground truth of labels. There's no label data set to train on because people don't volunteer their address information voluntarily and say, hey, this is me, right? So the little ground truth we're able to gather is from actually transacting with some of these exchanges. And so that's a small data set for supervised learning. So a lot of it is unsupervised clustering to try to classify which entities belong to each other. And then that leads to follow-on, of course, but that's a little down the line in terms of backtesting and predicting price movements.
So going back to the previous point, that one about the
Yeah.
exchanges, you can effectively use their order book data to identify the endpoints in sets of transactions, so you can identify their accounts. The fact that you can do that and they're not just creating loads of new ones to thwart you suggests they don't really care that you're doing that, right?
Yeah, we've seen differences in terms of exchanges. So some exchanges actually purposefully obfuscate their transactional traffic by, so in a blockchain, you have to spend transaction fees for every transaction. And so some exchanges we've seen voluntarily spend money purely for obfuscation purposes. So several $100,000 worth every single day just to hide the flow of traffic. So they transact from one address to another, to another, to another, so on and so forth. And they split it and essentially mix it across multiple addresses to obfuscate the flow of traffic. But that's a cost, that's an efficiency trade-off that they're making. They spend money to obfuscate folks like us, but then other exchanges are very transparent. And it kind of boils down to their users as well, where they have some incentive to be transparent because, feel free.
Sorry, can I just ask a slight follow-up to that?
Yes.
So if you've got a whale and the guy's got hundreds of millions he wants to get rid of, why doesn't he have one of his lawyers contact the lawyers privately from the exchange, do something behind the scenes, and so his original ID can't be tracked through the chain?
Yeah, that happens all the time. It's OTC desk orders. So the yellow cluster at the top right here, orange, yellow, is essentially an OTC desk cluster where large whales contact the corresponding person at the exchange to make an over-the-counter transfer. But the beautiful thing is it is visible on chain, but it's not tied to an exchange cluster. So when we see those exceptionally large one-time transactions, we can see them on chain, and then eventually, this is kind of where it becomes an art, not exactly a science, where we can see one or two hops down the line. Does it end up in an exchange? Then we have some sense of signal whether it's related to an exchange.
I've got two questions. The first one is, when there is a huge increase in the number of addresses, for example, does the problem become exponentially bigger? And if so, then do you need to change your methods or your infrastructure to cater for that? And the second is, what is your business model? Like, how do you make your revenue? Because quite a few things are free, so.
Sure, yeah, great questions. As of right now, our data set size is around like 5 terabytes for 2 blockchains, Bitcoin and Ethereum, just flat files. With more addresses, it does become, I wouldn't say exponentially harder, because we can trace the flow of funds to each address. So even if you generate new addresses, those addresses need to receive their funds from another address that probably you own, right? And so we can, those scripts are pretty efficient right now from our backend in terms of tracing the flow. And then in terms of the business model, right now we're serving institutional funds and also retail traders. So with these real-time alerts for when stuff is going to go down on an exchange before it actually happens, so that you can generate alpha.
Hello.
Hey.
So a follow-up to the last question. So basically, the way you monetize this flow is by front-running the human whale orders.
Yeah, to some extent. That's for like the real-time, really, quant-driven traders. And then we also have funds that have like fundamental theses where they want to invest in a certain token ecosystem and they want to judge its true valuation. And so they look at what are the types of actors that are transacting with this token.
So regarding the future of money, the title of your talk, do you think it will be regulated more in the future?
Yeah, 100%, 100%. It's already moving in that direction. There's, security tokens coming out where you can buy portions of a company in a token format and then have it liquid across all over the world, but it's regulated still. And so, and also in terms of the future of money, we see similar patterns emerging on chain as we see off chain. We see kind of these accumulation of funds in a few actors. A lot of these systems, as though they're promised to be decentralized, are not really that decentralized. They're pretty centralized. A few people hold the majority of the wealth, and they essentially move markets whenever they so choose, like happened at the start of this month, actually. A few whales moved the entire price of Bitcoin, moving the entire market.
Hi, Sid.
Hey.
Great talk. You mentioned you've used Neo4j for your graph database. What has been your experience? Because you said it was fun. Was it in a good way, or was it difficult with such huge volumes of data?
Yeah. So it was difficult to get it started and develop the right schema to put the kind of data volumes that we were dealing with inside Neo4j. But obviously, like from an ad hoc and analytics perspective, it's fantastic to do a query where you can see. So, like for example, last week a fund gave us an OTC desk that they were dealing with, the address of an OTC desk. And they were like, who else has this address been interacting with? Can you just give me an ad hoc query? We could easily query that address and give them a map of who all they've interacted with.
Do you have one Neo4j database, let's say, for a blockchain?
Yes.
Because it's not, you can't split it into clusters.
Yeah. So it is one large instance, but we have reads across.
And it performs.
In some use cases, it does. In some use cases, so it's not just Neo4j we use. We also use Cassandra. We also use Athena. So from the S3 flat files. So for different use cases, we touch different databases.
Any more questions for Sid?
Yes, related to that, what did you have to do to get the data into Neo4j? Was that a difficult task?
Somewhat. I mean, we had our data lake, which was in S3, Amazon S3, and we converted it into CSV files. Essentially, Neo4j has a batch CSV loader, and took like a few days, but we were essentially able to batch load the entire historical data set. And then we made a job, an ongoing job that runs for every single block that's mined to then load it into the database, different nodes. So batch CSV job to upload all the historical data, and then ongoing job to update.
So that makes the visualization a lot easier.
Visualization and like kind of these ad hoc analyses to say what's the contextual info about an address.
Okay, I think it's time to thank Sid for his talk.